Hi, welcome to NewTech YouTube channel. In this video, we are going to study and solve example on Z parameters of two-port networks. Let's start. Study some important terms. First term, one-port network. Statement, a network in which current enters through one terminal and leaves through another terminal. Refer the diagram of one-port network. Current IA entering into network and current IB leaving from network. Second term, two-port network. Statement, a pair of two-terminal network in which current enters through one terminal and leaves through another terminal of each port. See the diagram. Currents IA and IC entering into port 1 and 2 with currents IB and ID leaving from port 1 and 2 respectively. Up till now we have studied important terms in two-port networks. Let's study representation of Z parameters as if currents I1 and I2 are independent variables, then voltages V1 and V2 are dependent variables. Now Z parameters in equation form represented as voltage V1 is equal to open circuit impedance Z11 into current I1 plus open circuit impedance Z12 into current I2, which is given by equation 1, and voltage V2 is equal to open circuit impedance Z21 into current I1 plus open circuit impedance Z22 into current I2, which is given by equation 2. The open circuit impedances are represented in two-port networks with currents I1 and I2 as. Let's refer the diagram. A two-port network is given with currents I1 and I2 are inputs at port 1 and 2, and we are measuring voltages V1 and V2 at port 1 and 2 respectively. Please remember the currents directions at the time of analysis of given network or circuit. Let's study case 1 of open circuit impedance. Now substitute current I2 is equal to 0 into equation 1 of open circuit impedance. We get open circuit impedance parameter Z11 is equal to V1 upon I1, where current I2 at port 2 is 0. Now refer the given two-port network. Current I2 is equal to 0 means we are obtaining Z11 at port 1 only using voltage V1 and current I1. Now study case 2 of open circuit impedance. Let's substitute current I2 is equal to 0 into equation 2 of Z parameters. We get open circuit impedance parameter Z21 is equal to V2 upon I1, where current I2 at port 2 is 0. Refer the two-port network diagram. Current I2 is equal to 0 means we are obtaining Z21 parameter by measuring voltage V2 at port 2 and current I1 at port 1. Let's study case 3 of open circuit impedance. Now substitute current I1 is equal to 0 into equation 1 of Z parameters. We get open circuit impedance parameter Z12 is equal to V1 upon I2, where current I1 at port 1 is 0. Refer the two-port network diagram. Current I1 is equal to 0 means we are obtaining Z12 parameter by measuring voltage V1 at port 1 and current I2 at port 2. Now study case 4 of open circuit impedance. Let's substitute current I1 is equal to 0 into equation 1 of Z parameters. We get open circuit impedance parameter Z22 is equal to V2 upon I2, where current I1 at port 1 is 0. Refer the two-port network diagram. Current I1 is equal to 0 means we are obtaining Z22 parameter at port 2 only using voltage V2 and current I2. The open circuit impedance parameters of two-port networks in matrix notation form represented as voltage V is equal to Z into current I, where voltage V is equal to V1 and V2. Impedances Z is equal to Z11, Z12 Z21 and Z22, and current I is equal to I1 and I2. We just studied important cases of open circuit impedances. Let's solve example on the same. Example statement: find the Z parameters for the network shown. Let's see the given data. Resistance R1 is equal to 9 kilo ohm. Resistance R2 is equal to 12 kilo ohm. R3 is equal to 2 kilo ohm and R4 is equal to 4 kilo ohm, where currents I1 and I2 are independent variables and voltages V1 and V2 are dependent variables with ports labeled as 1 and 2. Solution: case 1. We are obtaining open circuit impedance parameter Z11 is equal to V1 upon I1 with current I2 is equal to 0 at port 2, means obtain current I1 in terms of voltage V1 and total resistance. Now calculate total resistance as total resistance is equal to R3 plus R4 parallel with R2 plus R1. Now simplify the equation and substitute resistance R1 is equal to 9 kilo ohm, R2 is equal to 12 kilo ohm, R3 is equal to 2 kilo ohm and R4 is equal to 4 kilo ohm into simplified equation. After calculation, we get total resistance is equal to 13 kilo ohm. The value of current I1 and Z11 are calculated as current I1 is equal to voltage V1 upon total resistance is equal to V1 upon 13 kilo ohm, which is represented by equation 1. We know open circuit impedance parameter Z11 is equal to V1 upon I1 represented by equation 2. Substitute equation 1 into equation 2. Then Z11 is equal to V1 upon V1 divided by 13 kilo ohm. After simplification, we get Z11 is equal to 13 kilo ohm. Solution: case 2. Here we are obtaining open circuit impedance parameter Z21 is equal to V2 upon I1 with current I is equal to 0 at port 2, means obtain current IA in terms of current I1 and then find voltage V2 across resistance R4. Using current division rule, we are finding current IA which is flowing through resistance R4 as current IA is equal to resistance R2 divided by R2 plus R3 plus R4 into current I1, which is represented by equation 3. Now substitute resistance R2 is equal to 12 kilo ohm, resistance R3 is equal to 2 kilo ohm and resistance R4 is equal to 4 kilo ohm. With current I1 is equal to V1 upon 13 kilo ohm into equation 3. After simplification of terms, we get current IA is equal to 2V1 divided by 39 kilo ohm given by equation 4. Using equation 4 of current IA, find voltage V2 as voltage V2 is equal to current IA into resistance R4, which is given by equation 5. Substitute value of current IA and resistance R4 into equation 5. After calculation, we get voltage V2 is equal to 8V1 divided by 39, which is given by equation 6. We know open circuit impedance parameter Z21 is equal to V2 upon I1, where I2 is equal to 0, which is represented by equation 7. Using equation 1 and equation 6, then equation 7 becomes Z21 is equal to 8V1 upon 39 divided by V1 upon 13 kilo ohm. After calculation, we get Z21 is equal to 2.67 kilo ohm. Solution: in case 3, we are obtaining open circuit impedance parameter Z12 is equal to V1 upon I2 with current I1 is equal to 0 at port 1, means we are obtaining current IB in terms of current I1 and then find voltage V1 across resistance R2. Using current division rule, we are finding current IB which is flowing through resistance R2 as current IB is equal to resistance R4 divided by resistance R2 plus R3 plus R4 into current I2, which is given by equation 8. Substitute resistance R2 is equal to 12 kilo ohm, R3 is equal to 2 kilo ohm and R4 is equal to 4 kilo ohm. After simplification, we get current IB is equal to 2I2 divided by 9, which is given by equation 9. Now, voltage V1 calculated as voltage V1 is equal to current IB into resistance R2, which is given by equation 10. Using value of current IB and resistance R2 into equation 10, we get voltage V1 is equal to 24 kilo ohm into current I2 divided by 9, which is given by equation 11. We know Z12 is equal to V1 upon I2, where current I1 is equal to 0, given by equation 12. Using equation 11, then equation 12 becomes Z12 is equal to 24 kilo ohm into current I2 upon 9 divided by current I2. After calculation, we get Z12 is equal to 2.67 kilo ohm. Solution: Case 4. We are obtaining open circuit impedance parameter Z22 is equal to V2 upon I2 with current I1 is equal to 0. Now calculate total resistance RE as refer previously studied diagram. Total resistance is equal to R2 plus R3 parallel with R4. Now substitute R2 is equal to 12 kilo ohm, R3 is equal to 2 kilo ohm and R4 is equal to 4 kilo ohm. We get total resistance is equal to 3.11 kilo ohm. Then current I2 and Z22 calculated as current I2 is equal to V2 upon total resistance is equal to V2 upon 3.11 kilo ohm, which is given by equation 13. We know open circuit impedance parameter Z22 is equal to V2 upon I2, which is given by equation 14. Now substitute equation 13 into equation 14, then Z22 is equal to V2 upon V2 divided by 3.11 kilo ohm. After calculation, we get Z22 is equal to 3.11 kilo ohm. Just recap. In this video, we have studied open circuit impedance parameters with its equations and calculations of parameters using two-port networks. Also, we have solved example on the same. Thanks for watching my YouTube channel. Thank you.